Good evening all, I am Vikram from AML department. Going to talk about the topic A-star search. So A-star search going on to before that, we are going to need to know about some few terminologies to related to A-star search. So the terminologies are heuristic values, weighted edges and nodes. So what are the heuristic values? Heuristic values are nothing but it is the shortest path or the optimal distance to travel from one place to another place or one node to another node, or which used to calculate the complex problems with optimal solutions. So that is known as heuristic values. And weighted nodes weighted edges are nothing but the distance that has been carried out by a particular node is known as weighted edges, or the cost or the path of a particular node from a particular node. So we're going to construct a graph. So which a graph has the starting point as yes, or we can able to take which has been some specific nodes. So which has been traveled to A, B, and C, and it has been deviated into like D, E, F, G. So it has been interconnected with A, B, and B has been connected. So the weighted edge of a particular node, as we said, is for this node it's 11, and for A it is 10, B it is 5, C it is 3, 10, 7, 3, 6. Distance between we need to check that, or we need the information. So that is 4, 2, 5, 5, and 3. So this is a kind of graph. This is a graph which has been constructed. So as we can say that which are the nodes S, D, E, and A, B, C, are all the nodes of the particular graph. So this is the distance between. So these are all the numbers which has been written between two nodes are the distance between the nodes, and the 11, 10, or the values which has been written above the node, which is weighted edges. So now we are going to draw A-star search, or we are going to implementation of A-star search on this graph. Before going into that, simply A-star search is nothing but it's an informed search algorithm or best first search, which used to find the total path length of from a node to a goal state. Which can be able to say it's also an estimation between from specific node or the starting node to the goal state with the optimal solutions. So as we know, the starting node it is S, which has 11 and split into A and D. So we know this is 3, 10. So this is 4, 10. So the distance which is calculated between A to S, it's not 3. It is actually 13. It's why? Because the formula of A-star search is nothing but F of n is equal to G of n plus H of n. H of n it is a heuristic value, and G of n is a distance between two nodes. So that's why we can able to get the value of or the distance between two nodes. So now it is 13 and 14. We know that which is at least one 13. Obviously, we are gonna further split this nodes into B and D. So the distance between A to D is 5 and B is 4. So now what is the weight of B? 5, D 10. So in this we should not just take the value or the distance between A to B and from a specific node to the goal node. So that we need to add the distance between A to S and A to B. So such that 3 plus 4 plus 5. So this is nothing but 7 plus 5, 12. So this is 3 plus 5 plus this is 18. And this is 4 plus 10, 14. So which is the most smallest one? We need to check D, D and this D also. Because this can also be a smallest value. Because this has a potential to be furthermore classified. So this has 12, so that we are going to further classify here itself. So B has been split into C and E. So the distance between C and B, that is 4, weighted that is 3, and E to B, that is 5 and 7. So distance 3, 4, 4, 7, 11, 14. 14. This is 7, 12, 7, 12, 12 plus 7, 19. So here 18 and 14. So now if we check 14, 19, 18 and 14, which is the smallest value? 14 obviously. In this first, when you take from left to right. So see, it is a leaf node. As it talks about the nodes, leaf node is nothing but the node which cannot be able to further classify. So the next possibility, D. So we need to further classify into D. So how D splits up? It splits into A and E. So the distance between A to D, 5. 2. So S, so we can take the distance for this 4 plus 2 weighted node. Sorry, I forgot about the weighted node itself. So for A that is 10 and B 7. So 7, 6 plus that is 13. 4 plus 5, 9, 9 plus 1, 19. Now we can able to put cross mark because we are not going to use this node again. So 19, 18, 19, 13. So 13 is the smallest one. So we need to further this E classify into F. Only one node is there, so we further classify it 4, 3. So that is 6, 6 plus 4, 10, 10 plus 4, 13. So again, if we check 19, 18, 19, 13, 13 is the smallest. So furthermore classified, we are able to attain the goal state itself. 3, 0. So this is the most optimal path to find out the goal state from a specific node. So that we can write it in the side S to D, D to E, E to F to G. So this is the most optimal path to find out from a specific node to a goal state. So A star search has been used in many real life experiments in AI and ML, like using in NPL, natural language processing, to make decisions in the machine learning algorithms, and video games, for example, to act the NPCs like intelligent persons, and using in video games also the characters to be dodge or block or move aside when it's an obstacle is there. So these are all types of which has been used in A-star search, or robotics also which has been used, etc. So these are all the practical applications of A-star search in our day-to-day life.